In this bonus lesson, we're going to talk about how we can generate the normal map as well as the height map for the floor that's used as the parallax mapping example in this training kit. Alright, so if you've had a chance to look at the floor for the parallax mapping training kit, you've had a chance to see the parallax map in action. Alright, now the parallax map is going to be great for being able to generate and reproduce things like these little spikes that come up out of the floor. Right? Things that actually have quite a bit of depth to them. So in this bonus lesson, we're going to talk about how we can generate the normal map and the depth map that will eventually be used in that parallax mapping example. Right? Now, for the most part, this whole process works very similar to the process of generating the normal maps and the occlusion maps for this game character that we had used a little bit earlier. So in this example, we have two pieces of geometry. One is this high-resolution floor, which has all these extrusions in it and a few spikes that have been raised up off the ground. And also in this scene, we have a low-resolution floor, which this low-resolution floor is just a simple grid. All right, now on this grid, we have a simple UV layout, just a straight planar. So what we want to do is use the Ultimapper, just like what we did before, to generate the height map and the normal map for this low resolution floor. So what I'll do is select the low resolution floor, go to Model, Get Property, and we'll get the Ultimapper, just like what we had before. Okay, it's going to ask us to pick our high resolution source, so let's pick the high resolution floor. What we want to be able to output is both a tangent space normal map and also a depth map, because both of these are going to be essential for creating the parallax effect. Now, if you look down toward the bottom of this property page, you have two options, one for a distance to surface and one for a depth range. Now, what these can do is if you compute this, XSI will basically fly a virtual camera through your scene to determine what's the maximum distance between the highest point of your high-resolution object and the lowest point of your low-resolution object. Right, so it'll compute the distance. Now, to make this computation happen much faster, it's going to be very important that you have your resolution or your quality set to a low value. Right, the lower this value, the faster this computation will go, but you won't lose any quality of the computation versus if you had it set up to a higher amount. So always make sure you have this set to a low value. Give this just a second to compute the distance. Alright, so it's going to go through and determine what's the maximum distance between these any high or low points. So once we have that, now we can crank up the resolution to something like 1024. We'll give this a nice high quality. And we'll go ahead and just hide the high resolution source. We'll give this a prefix. So we'll just call this floor. And I'll just switch this to a Windows bitmap, just so that it'll be a little bit easier to see once we generate this normal map. So with that done, we'll go ahead and generate. Give this just a second to compute this. Alright, so once that's been generated, if you want to take a look at this, just go back to the preview shader tree, and let's take a OpenGL preview of this, so we'll generate that. Now switch this to an OpenGL view. And there we are. There's what the normal map looks like applied to this low resolution object. So we really cannot see the parallax effect here in XSI, but because of the depth map that we also created with this depth map, those can be combined to create the parallax effect once we get back to Ogre. Right? So that's exactly the process that we go through to generate the normal maps and the depth maps for that particular lesson.